Welcome all. Today we are going to discuss the topic that is instruction set of 8051. Till now we have learned about the architecture of 8051, that is the first chapter, and in the second chapter we have discussed about the instruction formats and other topics also. Now moving on to the third chapter, that is instruction set of 8051. In this third chapter, what are the objectives that we are going to learn are listed in this slide. That is, the first objective is explain the function of data transfer instructions and effects of flags. Data transfer instructions. We have seen this classification of instructions in the second chapter itself. That is, there are different types of instructions depending on the function for which they have used. Data transfer, arithmetic, logical, and program flow control instructions. Such type of instructions are there. In that, the first objective is about the data transfer instructions, and second objective is explain the data transfer instructions with examples. So with the examples we should understand each and every instruction. And third objective is write programs in mnemonics to illustrate the application of data copy instruction. So the first three objectives are about the data transfer instructions. The data transfer instructions, what are the instructions available and what will they do, and we need to illustrate with them with a good examples, and we should write a small program by using such data transfer instructions. So these three objectives will be common for every group of instruction. That means if you see the fourth objective in this slide, that is the 3.4, explain the function of arithmetic group of instructions and effects of flags. Explain the arithmetic group of instructions with examples and write programs in mnemonics to illustrate the application of arithmetic instructions. So these next three objectives, that is 3.4, 3.5 and 3.6, are about the arithmetic group of instructions, and the next three, 3.7 and 3.8, 3.9 are about the logical group of instructions. And the other group of instructions available, that is the branching instructions. So the 3.10 objective, explain the function of branching instructions and the effects of flags. Explain unconditional jump instructions, and 3.12 about explain conditional jump instructions, and after that we have explain the bit manipulation or boolean instructions. So these two slides are showing the objectives of this third chapter that we are going to discuss in the coming video lessons. Today the first topic is the first objective, that is function of data transfer instructions. This is a classification of this data transfer instructions. Data transfer operations are grouped into three types, that is move type of data transfer and stack based and exchange based. If you see further in the move, we have three mnemonics, that is move, mov, move x and move c, and in the middle we have stack operations, that is push and pop, and again third one, that is exchange, we have xch and XCHD. These two instructions are on the exchange type of data transfer operations. Please note down this diagram or the classification. I will give you 1 minute for that. I hope everyone has completed drawing this classification chart. Now moving on to the topic, that is first point. This group of instructions copies data from one location called source to another location called destination. Right, these all type of instruction, that is data transfer instructions, uses copy type. That means from the source the data will be copied onto the destination, and the same information will be retained in both source and destination. That is meaning of copy. If you use the cut option, there is no cut option here, but in general if you use the cut means the source, in the source the data will be vanished and will be available only at the destination. But in case of move instruction, data transfer instructions, the data will be just copied from the source to the destination. Second point, in this operation source content remains unchanged and destination contains the content of source. This is what already we have discussed in the first point, that is the source content remains unchanged. It will just copy the source contents onto the destination. Third point is the data transfer may be between accumulator to registers and vice versa. The arrow has two sides pointed, so the data can be transferred from accumulator to register and register to accumulator is also possible, and register to internal memory location, register to internal memory location, and internal memory location to register is also possible, and external immediate data to a register or internal memory location, and accumulator to external memory location. So these all types of operations are supported in this data transfer instructions. The fourth one is during the execution of data transfer instructions no flags are affected. Yes, this has to be understood, because in the objective 3.1 if you see, explain the function of data transfer instruction and the effect of flags. What will happen when this type of instructions are executed? The flags we typically have, there is the carry flag, auxiliary carry flag, overflow flag, and parity flag. These four flags generally depend on the arithmetic operations, because by doing arithmetic operation only the result is changed, there is a chance of overflow and carry generation. But in case of data copy, that is moving the data from source to destination, there is by any chance there is nothing will happen to these flags. That means they remain unchanged. They remain unchanged. Flags are not affected. The examples, yes, we can understand each and every instruction with a good examples. With a good example, we can understand each and every instruction. In that, first if you see move a comma rn, move a comma on rn. In this, if you see, it's an instruction. If you divide and if you remember the instruction format, that is opcode followed by operand. Move is the opcode and the operands are a comma or n. Rn means register. It is a generalized register name because we have R0 to R7. The same R0 to R7 are represented with Rn, where n is a number from ranging from 0 to 7. So that is the register. And you know that A is a accumulator register. And is this particular instruction, Rn is the source and A is the destination. So what it will do, move space A comma Rn. The contents of register Rn will be copied onto the accumulator register. So that is the functioning of this instruction that will happen after the execution of this particular instruction. And the description part, if you see, move the contents of register R into the accumulator, and Rn represents the register from R0 to R7 correctly selected bank. And the operation, what it will do, the contents of Rn, parenthesis indicates the contents. The contents of Rn are moved into the A register. An example, if you see an example, the table move A comma R2. Here we have taken R2 register. Before execution, let us assume A has XXH, that means some random number, right, that is available in the already accumulator register. And the R2, which is a source register in this instruction, has this contents, that is 37H is the content this R2 has, and A has some random value. That is the before execution. If you assume these are the values, then after execution what will happen, the R2 contents will remain same, that is the source contents will remain same, but the destination, here accumulator register content are copied from the source register. So the contents of accumulator register will become 37H in this example. This is an illustrated example. You can take any internal RAM location in this example. You no need to by heart these for exams, but just remember the syntax and what it will do, the function. The operation, syntax and function are important in any of the instruction to write in the exam with a good example. So in the note section, this is explaining what is happened here. The note, the content of accumulator is changed. Content of accumulator is changed after execution, but contents of R2 remains as it is. This means contents of destination always change after data transfer instruction is executed. Yes, it is right, because the data transfer means data has to be transferred from source to destination. After the successful execution, the destination will have the contents of the source. So obviously the contents of destination will change before execution and after execution of this instruction. So that is a very important point here we should consider. So this is the first instruction in the data transfer type, that is move A comma Rn, generalizer register, that is R0 to R7. Next instruction in this data transfer type, I hope everyone please draw this example table, example table. You write it in your book, and if there is a quick revision possible before coming to tomorrow's lesson or before the examination time, then you can easily remember. And the contents of R2 are of your choice. You don't need to write 37H only, the same example in the examination. or you can write the same also. There is nothing to write worry that if you write the same example, then you may not give the marks the examiner. It's not like that. The example you can take any value. That means the same 8-bit number. Please draw this table. I will give you 1 minute. I hope everyone has drawn this example table. Now moving on to the next instruction in this data transfer type. That is, second instruction is move a comma hash data. The hash data, if you can remember in the second chapter, while we are discussing the addressing modes, different types of addressing modes. There, the first addressing mode is immediate addressing mode, in which we have the data is directly mentioned in the instruction itself, and in order to separate the immediate data from the direct address data, we use the hash, that is the pound signal before the data. That means while writing the instruction, we should place the data by appending hash before the data. The same example is given here. It is move a comma hash data. In this description, that is C, move an immediate data into accumulator. Note, immediate data is always presented by hash in the instruction. The immediate data in this instruction is always an 8-bit, because why? The accumulator size is 8 bits. The size should match. And the third point is immediate data can never be a destination. Yes, this is the restriction in this type of instruction. And if you can remember in the previous lesson, this addressing modes topic, immediate addressing mode, the hash data operand should not be the destination, it should only be the source. The operation, if you see, direct the contents are saved onto the accumulator register. In the example, if you take move a comma hash 32h, before execution a has some random data XXH, and the data is directly we are supplying, so it does not have any address. The data directly we are giving in the instruction itself, so available data is 32h. So after executing this instruction, the contents of accumulator are copied from the source, that is the immediate data given in the instruction, that is 32h. That is the accumulator contents are become 32h, and the immediate data. So now you know immediate after execution, there is no chance of retaining that immediate data. If we access that instruction itself, then we can see the immediate data. So this is another type of data transfer instruction. Now moving on to the third instruction in this data transfer group, that is move a comma direct. Move a comma direct. If you remember in the addressing modes topic, direct means direct addressing. Direct addressing, the address of the data which has to be accessed is given in the instruction. That is, there is no need of mentioning or writing hash before this data. So move a comma data. The content of the memory location, content of memory location, that is either internal RAM or SFR, whose address is specified directly in the instruction, is moved to the accumulator. So whatever the direct address we are giving in the instruction contains some data that has to be moved into the accumulator register. So that is mentioned in the operation part, that is contents of A are filled or copied by the direct, that is 8-bit address of internal RAM contents. So first we have 8-bit address of internal RAM or SFR available, on which address we have some contents, right? That is 8-bit data will be available at that place, and that will be copied to the accumulator register. With a good example we can understand this instruction. See the example portion, that is move a comma 40h. You can see that is move a comma hash 32 is a immediate data, and move a comma 40h without any hash. You can write move a comma 32h also without using the hash. In that case 32 will become the address of the content, that is we have to copy to the accumulator. So here the address is 40h. So before execution we have accumulator has some random data xx, and 40h contains, or 40h address contains the data of 99h. So what will happen, 99h contains 99h data present in this 40h address will be copied or moved into the accumulator register. So after execution what will happen, the accumulator A has 99h and 40h address has 99h. So note parenthesis means contents of. So in the three examples also we have seen the parenthesis around the accumulator A, that means the accumulator contents are copied from the source. So like this we can explain this type of instruction. So these are all these three are the part of data transfer instructions, and we have number of instructions also. We should see each and every instruction and learn each and every instruction what will happen, and with a good example we can understand before execution what is the data, and after the execution how it will change it. So we can see with good examples. Now moving on to the fourth data transfer instruction available. Yes, this number is continuing because we have around 20 to 26 data types of data transfer instruction only. Then after that we have different equations, so different instructions available in the next group, that is arithmetic also, next logical and branching type of instruction also. This entire third chapter is illustrative of each and every instruction available in the 8051. That means we have entirely 111, if you remember from the previous classes, that is 111 instructions, of which we have 49 are 1 byte and some around 19 or 17 2 byte and 17 3 byte instructions, right? So moving on to the fourth type of data transfer instruction available in this slide, that is move a comma array. Array, the symbol you have already seen this in the second chapter topic of addressing modes, where the symbol is used for indirect addressing mode. In the direct addressing mode we are mentioning the address of the contents from where we have to access the data. In the indirect, the contents, the data is placed somewhere, and the address of this data is placed in the contents of this register. That is double time is required to access the data. It is the relative address, or sorry, it is the indirect way of saying the data. So we have move a comma at the rate array. The description part, we have move the contents of internal RAM memory location whose address is specified by array to accumulator. Here we have used RI, not RN. RN means general N, that is 0 to 7, R0 to R7 you can use, but here we have used RI, or internal. So there is only two registers available for this operation, that is R0 and R1. In the note point, second point, in this indirect addressing mode, the registers used are only R0 and R1. The operation is contents of RI, which are the addresses which contain the original data. So that's why we have used double parenthesis here. Double parenthesis we have used to represent the operation. It is not a type mistake. Please understand that is RI is the internal register, that is R0 or R1, but the contents of RI is not beyond. It is not the direct representing of data. The contents of RI are the required address from where we have to access the data, and that accessed data has to be copied into the accumulator register. That's why we have here single parenthesis on the A side and double parenthesis on the RI. I hope you are getting this, because as long as we move on to the next type of instructions, we will get a little bit confusion, because there will be a number of instructions available, and remembering all of them at a time, at a single time, will be difficult for everyone. So please write the instruction and the operation part and the example at least 2 to 3 times at your leisure time. If you want to write it now, that is during the class, during this video lesson, it is well and good, but only the instruction operation, that's it. So that will be a good practice, so you can understand. It will be very easily and very fast also. So fourth type of instruction we have seen is move a comma at the rate RI. So this is an indirect way of saying the data. And the example to understand this instruction is, to see, that is, we have taken move a comma at the rate R0 or 0. So before execution, we have a accumulator register contents of data is some random data XX, and R0 has the data of 60H, but we don't need this 60H as a direct data, but we can access the data which we wanted to from this memory location, that is 60H. If you see 60H memory location, you will find the required data. So that is the indirect way of saying the data. And after execution, what happens? A will have the 82H and R0 will have 60H, and the 60H address will have 82H. So like this we can see the indirect way of writing the data type of instruction. If you want, you can write this at now in your homework book or separate book which you kept for this subject. I will give you half minute to write down this example. Please write all of it. Okay, I hope everyone has completed this example. And moving on to the next type of instruction, we have mov space rn comma a. This is, if you see, this is the reversal of this operands from the first example we have seen, that is move a comma rn. The same type of data instruction is again repeated, but with the operands are interchanged. That is, here the a is the accumulator register is the source and rn is the destination. Rn is a common register within selected banks that we have, or 02 or 7. So the description here is move the contents of accumulator into register Rn, that is Rn to the left, and by the arrow mark if you see the contents of accumulator register are copied onto the Rn register. And the examples are move R5 comma A. Yes, in this slide I didn't mention the example, but if you want to write in the exam, if we have time, then we can write, that is the instruction move R5 comma A, and before execution the A has some data, that is 80H or 07H or 52H, some random internal data value, any 8-bit data value. 00H also a data, it may be a 00, but it's not some unexpected or some malfunctioning data, so not a random data, so 00H also you can write. So the accumulator has some value 32H, and the Rn register which we have mentioned in the example is R5. So before execution R5 has some random data XXH. So after execution, to the right side of table you can write the accumulator is 32H and the R5 is also have 32H, as the contents are copied from the source to destination from the instruction, this instruction move Rn comma A. And the next instruction, that is the sixth instruction, is move Rn comma hash data. Hash data means immediate data, but we have seen the instruction move a comma hash data. The immediate addressing mode supports this instruction also, move Rn comma hash data. That is, any register R02 R7 is the destination, and the immediate data we supplied in the instruction is the source. So you can write with the example move R2 comma hash data. And the seventh instruction in this data transfer type is move Rn comma direct. Move Rn comma direct. We have seen move a comma direct. In that, the direct address contents are copied onto the accumulator register. Now instead of a we have Rn as the destination, but the source is same, that is direct address. The address won't be copied, but the contents of the address are copied onto the Rn register. So description part is the content of memory location, that is internal RAM or SFR, whose address is direct specified in the instruction, is moved to register Rn, where Rn is any of the 8 register of the currently selected register bank. So the operation is represented, the contents of direct memory location are copied onto the memory, that is Rn location. So the example of move R3 comma 42H, that is, we don't use hash symbol here because it is not a immediate data, it is a address, direct address. So move the contents of memory location addressor 42 into the R3. So with this, like this, we can see different instructions till we have 10 more minutes, so we can see one or two extra data transfer type of instruction in this today's class only. So the eighth type is move direct comma a. Move direct comma a. Till now we can see move a comma direct, move rn comma direct. Now the possible instruction is move direct comma a. In this, a is the source, direct address is the destination. Yes, this is possible. What if we see move hash data comma a, move hash data comma c? Thus that type of instruction have we seen in this lesson. Is that possible? Move hash data comma a. That is illogical and it is not possible, because hash data cannot be used as a destination, so that is a illegal instruction. That is not possible to copy the contents of accumulator and that. Where we have to copy that the data is a direct supply of content, it does not have any address, so we cannot use data as a destination, but we can use direct, that is the address, as a destination in the data transfer instructions. So we can write move direct comma a. In that, accumulator is the source and direct is the destination. So the description is the content of accumulator is moved to a memory location, that is internal RAM or SFR, whose address is directly specified in the instruction. So the operation is direct with parenthesis and the arrow mark towards the direct and the parenthesis of a, that is the contents of accumulator are copied onto the direct address. So the example is move 40h comma a, that is contents of accumulator are copied onto the address location 40h. So the example, if you see before execution, same example, move 40h comma a. Before execution, let us assume 40h, that is the destination, has some random data, that is XXH, and the a, the accumulator, has some data, that is 17h. You can change this 17 to your like any 8-bit data is also possible. So after execution, what happens? The 40h contents, the register will have 17h and the a accumulator have again the 17h, because the data is just copying in the data transfer group. First slide of this today's lesson that we have seen, in the data transfer, the data will be copy only, it will not erase the source registers data. So it will keep the data in both places. It will just move the data, it will just copy the. So as we have left with 5 more minutes, we can quickly recap the type of instruction we have learned. We have started today's video lesson with a introduction of third chapter, that is instruction set of 8051, and we have already looked at the topics, that is objectives of this third chapter. Most importantly, we have the different instruction sets and different instruction groups available, that is data transfer and arithmetic group and logical group, and again the last one is control of program control instructions. So we have to see what are these groups of instructions and what happens when they are executed. That means whether the flags are affected or not. First one, important one, is flags. If the flags are affected, then the program flow will be more complex. That means we have to use, whenever we use these flags for our advantage or in the program, should see whether there is an instruction which is affecting these flags or not. Then after the result, we should plan the remaining course of the program. So the first objective is data transfer instruction with effects of flags. Second is data transfer instruction with examples. Yes, we are looking all the instructions with each and every instruction with a good example. And a program in mnemonics. So after completion of discussing the entire instructions available in a particular group of instruction, we can write simple program to have an idea how they are executed, how the program has to be written. And the next objectives of different group of instructions also we have seen only the heading. And in the first topic we have seen the classification of this data transfer, that is different types of data transfer instructions available, that is move type, stacks and exchange. We have till now we have seen the move type, in which we have only have the instruction that is mov mnemonic only. We didn't go up to move x and move c, till we have to go there, and after that we have to go push and pop instructions, and after that exchange and exchange the data. So the most important thing, this is the data transfer. What it will do, it copies the data from one location source to another location, that is called the destination. And there are different types of source and destinations we can write, that is a and registers names, and registers to the one side and internal memory location on the other side, and external data also one side and register on the next side also. So like this, there are different types of addressing modes and types we can access the data also. And most important thing is no flags are affected. Yes, this is the most important thing, because only the contents are copied. There is no generation of parity flag, that is the parity will not be affected because contents are just copied. So the number of ones will not be changed, number of zeros won't be changed, and the auxiliary carry and carry bit is also not used, because we are not doing any addition or subtraction, so that there is no possibility of generation of carry bit also. And overflow is also not possible. So these all flags are remain unaffected within this entire data transfer type of instructions. And after that we have seen up to 8 instructions in this. The names also you can remember, that's move a comma rn contents are moved onto the accumulator, move a comma hash data, direct data are copied onto the accumulator register, move a comma direct, the address is given, the contents has to be fetched from direct address and they have to copy it onto the accumulator. And at the rate array indirect address, the contents of the memory location which is the content of this indirect register mentioned will be copied onto the accumulator register. And to the left we have accumulator, that is the destination. Till now the up to 4 instruction. After that, to the right side we have the accumulator and register in the destination part. Rn comma a, rn comma hash data, rn comma direct, and direct comma a. So till now we have seen 8 different data transfer instructions, and further, yes, we have more data transfer instructions available in this 8051. We can see them in tomorrow's class. So it may be a hectic topic for you, but you have to write down all those instructions for watching tomorrow's lesson. Thank you, one and all. Please come prepared for tomorrow's video lesson. Thank you. I'm closing today's lesson. If you have any doubt, please mail me at sureshakol2001 @gmail.com.